Alright, today we're going to start talking about the periodic table. You did some reading and some notes from chapter 18, and as you saw as you go from left to right across the periodic table, the rows that go across are called periods. So let's label those. And we're going to number them, starting at the top. Period 1 is row 1, period 2, period 3, period 4, period 5, period 6, and period 7. We have 7 rows. What you need to know is that the periods are also the same as the number of energy levels. So that equals the energy levels. Now, as you go, we also have columns that come down, and we're going to go ahead and number those. They are called groups, and sometimes we call them families. And we're going to number them 1 through 18. 1, 2, 3, and so on. Okay, and as you can see, there are 18 columns or groups. The groups are also called families because they have similar properties, just like people in your family might all have brown eyes, and so you have similar characteristics or properties. Well, that's why the elements in a column are called families, because they are similar. They're not identical, but they are similar. Now, the number, just like over here, periods told us the number of energy levels that the atom has. The group number for the two towers. Notice you have a tower here and a tower over here, kind of two big towers, with the middle being kind of like a bridge. These, circle them 1 and 2, and then skip the bridge and go to just the 3, just the 4, leaving out the 1, 5, 6, 7, 8. Those are the number of valence electrons. Valence electrons, as you saw from your reading, is the outer electrons in the energy level. All right, so that is one way that the periodic table is organized, by rows that we call periods and columns that we call groups or families that have similar traits because of these valence electrons. Another way they're organized is what is by sections, and those sections are metals, nonmetals, and metalloids. And when you have time, you can maybe color these. Right now, we have a staircase line going down, and that separates the huge section to the left that are the metals. So let's go ahead and label these metals. To the right, we have nonmetals. Again, all separated by the staircase line. And on either side of the staircase line, we have our metalloids. So up here, let's add to our key here, and we can make diagonal lines there. And we can do that here. Starting at the top, the line comes down and over, so the first box in 13. This is aluminum, and it is special. It is not a metalloid. It is a metal. So we're not going to color aluminum in, but you might want to write that in there and circle it. And then we do have the one to the right of the staircase. And then we just go down both sides of the staircase line. Left side, right side. Left side of the line, right side of the line. Left side, right side. And you might wonder about down here. Well, down here we don't have any new elements down here yet. Those are holding a place for elements for later. So, metals, except for hydrogen here. Hydrogen is also special. It is a non-metal that you'll learn why in a minute. It's over here. Okay. The next thing is we have a special set of metals, and they are right here in the middle. They are the bridge. So this area right here, that bridge, so to speak, between the two big towers, the bridge, is called the transition metals. Okay, so write that. And then notice this little line here. What that means is this section down here actually fits right in there. And the reason we don't put it in there is because it would make our periodic table take up the entire length of the room. So this fits up there. These are called the inner transition metals. And they have names. This top row, because this element right here is lanthanum, these are called the lanthanides. And right below it, we have actinium. And so this row are called the actinides. Okay. We're going to stop there for a second, make sure you have everything.